Hello again, my little children. In this video, we're going to be talking about 2.1, and it's all about functions. You've heard about functions before in Algebra 1. So just a reminder, a function is a set of numbers that have a unique output for each input. So all that means is if I have an x value, it will have only one y value. Unique just means only one. Sometimes the independent variable, that is our input. Well, not sometimes, all the time. Our independent variable is our input. Our dependent is the output. It is independent because we can put whatever we want in for it, and the dependent is because it depends on what we put in for our input as to what we get for our output. Our input and our independent variables are also known as our domain usually, which is the x values possible in our set. The range is all the y values in our set. No, I don't care. A relation is just a set of numbers. So like, a relation is really anything. They can relate anything. We can have multiple x values, multiple y values that are all the same. It really doesn't matter. They can all be different. So I'll kind of talk to you guys and I'll show you different ways you'll see things. So for this first part, we're going to be determining if the following is a relation or a function. Then we'll state the domain and range and interval notation for each. I'll show you what interval notation is as well. It's pretty simple. Relation or function. So remember, function only has one y value for each x value. So all I do is I check the x value. Our independent is our x value. So 3 is going to 15, 6 is going to 4, 12, 15, 14, 11, 28, 22, 8. So each of my x values are only going to one y value. Let me move that over a little bit. I'm sorry. My head's too big. Can I make this smaller? Can I make you smaller? No, it just moves it out. We'll do that. My head's in the corner. All right. I'm out of oh wait, wrong way. I'm out of the screen. I'm out of the screen. Sorry. Okay, here we go. All right, we only have one y value for each x value. So that makes this a function. Yay, we have a function. All right, so for the domain, that's our possible x value. So since they are solo, I have 3, 6, 12, 14, 20, 22. So I'm just going to list these as points. 3, 6, 12, 14, 20, 22. All right, so it's all of those. Then for my range, it's just the possible y values we have. So again, I'll just list this set, 4, 15, 8, 11. I like listing it in order. You don't have to. It really doesn't matter. But those are the y values that are in our set. That's all the range is. All right, moving forward. Remember, we're just saying, is this a relation or is it a function? So with this one, right off the bat, looking at that 7 is going to 23 and 10. That right there tells me this is only a relation. Again, a function has only one y value for each given x value. So relation, I'm done. I can list the domain and range. So I have 1, 7, 19, 30. That's a 3. And the range looks like I have 2, 5, 10, 17, whoops, I missed one, 13, 23. So it's all the possible range there. All right. Here, there's not really a domain or a range. It's just telling us what this stuff is. So really, this is just a relation where, I mean, there's not really a domain or range to say, so I'm just going to say this is a relation and be done with it, because there's no function. It's just how things are relating with each other. All right, moving on. Now we actually have graphs. So this looks like it's a sideways quadratic, which you'll learn more about coming up soon. Yeah. So the other thing, to test whether something is a function or a relation, we have something called a vertical line test. So what that is if I run a vertical line somewhere on my graph, doesn't matter where it is, for this given x value, it has 1, 2 y values. So it's a vertical line because it's checking for this single x value to see how many y values are associated with it. If that vertical line ever hits more than one time, this is not a function. So this is just a relation in this case. I can't spell. Relation. Relation. That says relation. Relation, 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 relationship. Oh! Sorry. All right. So for the domain, now it looks like it's starting from 0 and it's going forever to the right. So it's including all of the x values and between 0 and it's going to infinity. So what I do is I draw a bracket. This bracket is indicating that 0 is a part of my domain. 0 is included in the domain. We'll see one in a minute where something is not. So this is going from 0 to infinity. That's all I'm looking for. This is called interval notation. It's going, for my x values, they're going from 0 to infinity. It is always least to greatest. The bracket denotes something that is included. If we have a parentheses, it's something that's not. I always put a parentheses around infinity because if you tell me that it's included, then I'll just put a +1 on it, and that's still a part of domain, but it's not included. So there's no real set bound to infinity. It just keeps going. So there's no like included or not included. I'm just going to say not included because it keeps going even past what I include. Kind of, it's a weird conversation. But infinities are always parentheses. All right, so with this one, if I run a vertical line anywhere on my graph, it only ever hits that vertical line at one given point. So this is a function. And the domain, it's going left and right forever. So negative infinity to infinity. I just realized I didn't do the range on that last one. For the range for this one, it's starting from 0, it's going up forever, so it's going from 0 to infinity. For the last one on the range, it's going up and down forever, so the lowest y value is negative infinity, the highest y value is infinity, so it's everything in between negative infinity and infinity. All right, and there was the range for the other one as well. All right, for part F here, vertical line anywhere on this, it only ever hits at one given time, so this is a function. For the domain, it looks like it's going left. This would have an arrow, that would have an arrow, left and right forever. So it's going from negative infinity to infinity. For the range, it's going up and down forever. So it's going from negative infinity to infinity. Yay, that's really all it is. All right, G and H, I'm not going to worry about stating the domain and range. The domain is all of the x values. The range is all of the y values. Same thing with H, all the x values, all the y values. The only thing we're going to check for is whether it's a relation or a function, so you get used to seeing them in tables as well. So here, if I have 0, it's 0. There's no other x values. I'm really just mainly looking for repeating x values. 0, 1.5, 2, 2.5, 3, 3.5, 4. They're all different. It doesn't matter what the y values do, whether they're the same or not. So this is a function. So here, I'm looking at repeating x value. If they have a different y value, then it's just a relation. So there's a repeating x value. If I look at the y values, they're also different. So this is just a relation. They're going to get you if you look at the same x values, but if this were -1 instead of 3, then this is a function. It's just listing the same point twice for some reason, but it's still fine. It only has one y value for the given x value. Sometimes they'll just list them multiple times. I don't know why, but they do. All right, moving on. So part I is a little bit weird. This is called a rational function or reciprocal function, depending on who you talk to. What this is right here is it's actually an asymptote, which just means it's something the function is going to but never actually touching. You'll see these on your quizzes. They're kind of weird, so I want you guys to know about them. These are functions. These are completely fine, and they are functions. If you run a vertical line, it's only going to hit it once. I know this looks like it's going up and up and up and up and up, and eventually it'll go straight, but it's really changing very slightly in the x-axis as it goes forever. So now for the domain, I have everything except for 3. So the way I write this is negative infinity to 3, and I'm going to put a bracket because 3 is not included, and then I'm going to draw this little u. This little u just means or. So my domain is either in this part, or it goes from 3 to infinity. All of those x values are a part of my domain. For the range, it goes from negative infinity, and it looks like 0 is not included because of my asymptote there. It gets closer and closer to 0 in this direction, but it's never going to touch it, I promise. And it gets closer and closer to 0 in that direction, it's never going to touch it, I promise. And we're going to go over these functions a lot more later on in this course, so don't feel like I'm leaving you out. We will cover this in depth, and you will understand this, I promise. I think I said I promise like 5 times. I'm going to take care of you guys. That's all I'm getting at. I'm here for you. So negative infinity to 0 and 0 to infinity. Cool. All right, with J. So with this one, this is kind of like what we saw up here. This actually is a rational function itself. This is a reciprocal function. This is the equation of one. So these will be functions, I promise. Now the thing I need to notice here is you cannot divide by 0. So the only thing I cannot have is I cannot have 0 in my denominator. If it were 0, that would be -4. So for our domain, our x values, I have everything except for -4. It's everything around -4. So negative infinity to -4 and -4 to infinity. All right, moving on. The range, this one's kind of weird, so don't worry about this one too much. There's something called horizontal asymptotes, and it's just, don't worry about it too much. If you guys come up with something on the quiz, shoot me an email, let me know, and I'll help you guys out with that one, I promise. I don't expect you to know all these rules that I know right now. We're going to learn them, though. Yeah, you guys are going to be awesome by the end of this. I can tell I'm already going to like you guys, even though I haven't met any of you yet. I'm looking forward to meeting you guys, though. All right, so here we have a square root. The only type of square roots we know that we cannot take right now are negative numbers. So for our purposes, this has to be 5 or greater. Ooh, thunder. All right. This is a square root moved to the right 5 up 10, and it's actually reflected over the x-axis. So it's going to look something like that. So if you wanted, you could graph this in your calculator and see what it looks like. This will be a function. And the domain is going to be everything from 5 to infinity, so it has to be bigger than 5. And the range is actually going to be everything from -infinity to 10. Kind of weird. So again, on these last two, if you see something like that on your quizzes, let me know. If you see it on your test, let me know, and I'll kind of help you guys out with those. All right. Evaluate the following using the given value. So remember, for evaluating, I have this function f of x equals 3x minus 7. Now it's telling me to evaluate f of 9 and f of -3. Notice instead of an x, now I just have a 9. So all I'm going to do is say f of 9, and instead of x on my equation, I'm going to put a 9, so 3 times 9 minus 7, which would be 27 minus 7, which would mean f of 9 is 20. If we wanted to, we could rewrite this as the ordered pair, 9, 20. So all that means is x is 9 and y is 20. Our output would be 20. All right, and then it says f of -3, so I'll do f of -3 in the same manner. So 3 times -3 minus 7, so that would be -9 minus 7, which will be -16. So f of -3 is -16, or I could write it as -3, -16. That's it. All right, moving on. We're almost done. Doing good. Okay, so I have s. I should have written this as s of x. I messed up. I'm sorry. And s of -4 and s of a plus 2. All right. I did it on the next one too. Oh well, we'll go. So all I'm going to do is substitute -4. So s of -4 would be, if I were to substitute -4 minus 3 and -4 plus 5. So this would simplify to -7 over 1, which is just -7. So I could have the point -4, -7. All right, the other side, now I have, notice I have a plus 2. Don't let that throw you off. We're still doing the same thing. So s of a plus 2 is going to be super important to notice. There's nothing crazy going on. I'm just putting in a plus 2 wherever I see x in my function. It's going to be important going into pre-calculus, because we're going to start to use something called the difference quotient, but let's not worry about that right now. I'm just foreshadowing. All right, so I substituted in a plus 2 for the x value, and then I'm just going to simplify. A and then plus 2 minus 3, so that would be a minus 1, because there's nothing to like distribute to the a plus 2, over a plus 2 plus 5, so a plus 7. And that's what we would be looking for. That's probably what your answer choices are going to be. All right, this one is going to work just a little bit differently, but it's still the same idea. So again, I'm sorry, I should have made that t, and I should have made that t. My bad. My b-yo! So I have t of x is 2x squared plus 4. So if I have t of 8, I have 2 times 8 squared plus 4. So now I'm going to have to follow the order of operations, really for the first time throughout this. So I have to do 2 times 8 squared. Remember, do the exponent first. So 8 squared is 64. And then I still have that plus 4. Now I have to do 2 times 64, which is 128 plus the 4. And then 128 plus the 4 is 132. So I have t of 8 is 132. Now this other side is going to require just a little bit more work. So we're going to actually have to like distribute and multiply. It's going to be a lot of fun. I really enjoy these. So if I have t of h plus 3 now, so t of h plus 3 equals 2 times h plus 3 squared plus 4. Again, you got to follow order of operations. So in doing that, I need to make this 2 times h plus 3. Here, I'll do something to help you out. So I want you to remember that this is h plus 3 times h plus 3 squared, right? So now I need to distribute the h to both terms, the 3 to both terms, so this becomes 2 times h squared plus 3h plus 3h, right? So I distributed the 3 again, plus 9, and then plus 4. And then we can distribute the 2. I usually go ahead and combine these like terms to make that just 6h. And really, if you're cool jumping from this step, h plus 3 squared, to h squared plus 6h plus 9, that's what I do. But if you're not cool, then make sure you take the time. I don't want you guys to get these wrong trying to rush. Take your time. There's no rush. Make sure you guys are getting good answers out of this stuff. But this would be 2 times h squared plus 6h plus 9. That plus 4 is still on the outside. So now I distribute that 2 to all of my terms. So this becomes 2h squared plus 12h plus 18 plus 4. Now I can combine those two terms. And this is the last step. We're almost there. So 2h squared plus 12h plus 22. Beautiful. All right, that's going to be super handy going into pre-calc. Again, whatever questions you guys got, let me know. I am here for you. My monkeys are here for you. My bananas are here for you. So it's a monkey. It's a face. Well, no face, but it's a head, the body, leg, arm, banana, tail. It's all the components of a monkey. It totally makes sense. All right, I'll see you guys soon. Bye-bye.